Hello everyone, as we continue on our journey through the Year 12 Maths Methods course, we're continuing on with transformations, or our knowledge of transformations, as we look at how to determine a function from a graph, or from, I should also say, or from key information. So our learning intention for this topic is to use our knowledge of transformations to identify the equations of a function. And success criteria that we could judge that by would be write an equation of a function just by looking at its graph, if we're given enough key information, or also we could be told a couple points the graph goes through and use those points to find the equation of the graph. There's an example there. We are given a picture of a truncus that has a asymptote at x equals 2 and an asymptote at y equals -3. And we can also see its y-axis intercept is at 0, -11 on 4. So using those, it's saying find the values of a, h, and k. So that's what we're heading towards. So first off, we're going to actually start by looking at if we're just given points on a line. So here's sorry, my tablet's not working quickly. Replug that back in. Here we go. Lovely. Okay. So we're going to be using information we're given about the curve. This mostly should be a review from last year, but if not, I'm going to still go through all these worked examples for you. I'm going to go through the algebra component of it pretty quickly. I feel by now we've been really working on algebra skills and they're probably getting better up to scratch. So it's more about the concept of knowledge. So I'm told the points 2, 7 and -1, 1 lie on the curve with an equation of y equals a on x plus b. Now, when x is in the denominator like that and it's not squared, we can tell that this is a hyperbola. It's not a full standard or general form of the equation, but we're told that the equation looks like this, so that's reducing the amount of variables we have to deal with. Find the values of a and b. Well, whenever we're given points and we're not told that they're key things, like we're not told they're the asymptotes, or the starting points of a square root graph, or the turning point of a quadratic, or the point of inflection of a cubic, if they're just general points, then the only thing we're left with, the only option is we just have to substitute those points into the equations. We'll end up with two equations and we'll have to solve using simultaneous equations. So we'll do that. Let's sub the point 2, 7 into y equals a on x plus b. So we get 7 equals a on 2 plus b. And to make this a little bit easier to deal with, I'm going to multiply everything by 2 to get rid of that denominator. So I end up with 14 equals a plus 2b. The second one, I get 1 is equal to a on -1 plus b. I'm going to again multiply everything by the -1 to get rid of that denominator. So I get -1 is equal to a minus b. And that's my second equation. So we'll continue on with our solving on the next slide. My equation was 14 equals a plus 2b. 14 equals a plus 2b. And -1 is a minus b. So we're just going to solve them using elimination. We could also solve them using substitution, so rearranging one of these to get one of the variables by itself, and then subbing in and then solving. But in this case, we have the nice situation where we have an a and an a, so we can use elimination straight away, and we don't have to do any changes to either of the two equations. So what I'm going to do is I'm going to do equation 1 take away equation 2. So set them up like a normal subtraction algorithm that you would have done in primary school. Take away, and I put everything in brackets just to help remember about any sign issues. I'm going to do this take away working down. So I've got 14 take away -1, so that gives me 15. A take away a cancels out, and I've got 2b take away -b. So that's effectively adding a b, so I get 3b. So now I have 15 equals 3b, and I can just solve algebra. So I get 5b. So I put that in there. I'm going to sub that back in. plug in b equals 5 into, and I'm just going to put it into equation 2. You can put it into equation 1, it doesn't matter. I get -1 equals a. Take away 5, take that over, I get 4 equals a. And done. That's all it is. Now, this question just asked us to find the values of a and b. It didn't ask us to find the equation. Now, if it asked us to find the equation, we would need to go back and actually write y equals, what was that, a on x plus b. Therefore, we get y is equal to 4 on x plus 5. If you're asked to find the equation, in this case we weren't, so you could have just left it at a equals and b equals. Right. On to the question that's actually exactly the same as our success criteria. So if we can do this now, well, then we're meeting our success criteria. But we have graph shown has the rule y equals a on x plus h all squared plus k, and we're given key information. Now, the really handy thing about this situation is we're given what we could call critical data or key points. In this case, it's the asymptote. Now, we know if x equals 2 is an asymptote, h must be equal to 2. Now, I'm going to leave that as h equals to what we generally refer as h equals to 2, what we normally think of h. I'm going to show you a gotcha in this question. Maybe you've recognized already, but that's a plus h there. Now, normally the general form of the equation is y equals a on x minus h all squared plus k. So it's just, we're going to have to pay really close attention to that. What we could say is negative h is equal to 2. That's what we're used to seeing, is minus h. That would be our 2. And then our k is equal to -3. So if we sub these in, because there's that plus in there, we actually have to write h is equal to -2. So we get y is equal to a on x minus 2 all squared plus, subtract -3. So we've got already 2/3 of it done. We've got h and we've got our k value just by looking at it, because we know these patterns in the transformations. All that's left is we have to sub in our other point. So we're going to sub in -11 on 4 to find a. Now if we sub those in, they go in for y and x, and all that's left is a. We just use algebra to solve. So we get -11 on 4 is equal to a on 0 minus 2 all squared minus 3. And this is one of the times I'm just going to go through, do the problem, and not talk through the algebra. -11 on 4. Now I'm going to add the 3, but instead of writing it as 3, I'm going to write it as a fraction over 4. So to get 3 as a fraction over 4 times 3 by 4 is 12. 12 divided by 4 gives me a 3 equals a on 4. So we get 1 on 4 is equal to a on 4. Now, equating the numerators, because the denominators are the same, it's quite clear that, in this case, 1 is equal to a. And that's it, done. Again, it's not asking us to find the equation, just asking us to find the values of a, h, and k, which we have done. That's it. You could have also this last step. Just multiplied everything by the 4 in the denominator here to cancel. That cancels and it leaves us again with 1 equals a. Rightio, last example. Again, back to one of these situations where we're not actually given a graph. We're just given 2 points. Now, a graph has the rule y equals a square root x minus h. Passes through the points 3, 6 and 15, 12. Find the values of a and h. we're not told those 2 points as one of the endpoints or the starting point of a square root graph. We know a square root graph generally has a starting point and goes. Now, we're not told anything about that, so we can't infer h from this. We can't infer k. We're just told it goes through these 2 sets of points. So we just have to substitute in and again solve using simultaneous equations. So I'm going to sub in 3, 6, so I get 6 is equal to a square root 3 minus h, and I'm going to sub in 10, 12. 12 is equal to a square root 15 minus h. Okay, now we have to deal with these using simultaneous equations. So how are we going to go about this? We could try and rearrange one of them to get a by itself, and then substitute, or get h by itself and substitute that into the other one, and then solve square roots. When we have when one of the variables is a product like this, so we have a times by the rest of it, a times by the rest of it, I might call this equation 1, and I'm going to call this equation 2. What we can actually do, you've probably rarely ever seen it before, but we're allowed to do 2 divided by 1. We can do any operation with the 2 equations. We could multiply them together, we can divide them. I'm going to divide them because if I divide, I get 12 on 6 is equal to a 15 minus h on a square root 3 minus h, and because I have an a in the numerator and denominator on the right hand side, I get to actually cancel. And so what I'm left with is 2 is equal to the square root of 15 minus h square root 3 minus h. Where do I go from here? Well, I could square both sides, because if I square all of that, we can use our index laws where if we had a on b all squared, that's the same as squaring the first, as squaring the numerator and squaring the denominator. So let's do that. We've gotten to this stage. I'm just going to square that side, and I'm also going to have to square that side. So I get 4 is equal to, and since I've squared, actually I'll write it out. If h, I've squared that, over square root 3 minus h, squared that. That's going to cancel out the square root signs. So I'm left with 4 is equal to 15 minus h on 3 minus h. I'm going to take the denominator over to this side, just multiplying both sides by the denominator. So I get 4 bracket 3 minus h is equal to 15 minus h. 15 minus h. And just solve from there. I can get my brain to work. Let's go. Add that over that side, take that over that side. So I'm going to get negative 3 by taking the 15 over and add the 4h to that side. Is equal to 3h. So h is equal to negative 1. Right. I'm going to then sub that back in. Sub h equals negative 1 into, let's pick equation 2 again. Again, doesn't, actually no, let's go equation 1. All the numbers. So we get 6 is equal to a square root 3 minus negative 1. Careful with the signs, there was a subtraction up there. So we get 6 is equal to a square root 4 minus 6 is equal to minus by 2. A is equal to 3. Again, it hasn't asked for the equation, but just to write it out so we are clear, y is equal to 3 square root x. Now, it had subtract h, so we put negative 1 in there for h. That actually turns into plus 1. And we're done. So the new bit in that is probably the trick around dividing simultaneous equations. You can do that when it's a product, and because the two variables in this case are a and a h, the h that is inside that term, inside that square root, is multiplied by our other variable. Normally with simultaneous equations, we're used to like 3x plus 4y is equal to maybe 2. Two variables are separated by an addition or subtraction. In this case, they're not. They're separated by multiplication. So the division trick is very handy to get rid of it. That's it. I hope that helps. If you have any questions, feel free to comment below or ask in class, or shoot me an email.